Hi, I'm Jose Crespo-Barrios, and today I'm going to make some observations on the presentation of today of Iwasaki. Today is 15th May 2024. Respectfully said everything, of course, and is regarding for the international conference held and so-called United for Fight 2024. So bring me the cell phone, please. Okay, thank you. So here, this is a perspective of the COVID. This is an approach of the COVID that respectfully said, as I said, this is of 2021. At least the people who know me, that's the things we said in that by that time. I have a video, in my channel about 2022 about the viral persistent long COVID, and we decided the first treatment in April 2022 with Paxlovid, but also I wanted to make some comments about that today. The point is that this picture, for those who know me and were in the Telegram in at COVID persistente or t.me//COVID persistente. All the information is there, but in Spanish, but all the information was there by that time. And actually in the paper, very, very, very famous paper of Davis, a girl, is basically all the information that were in the Telegram by us and copy-pasted there. Respectfully said. So not copy-pasted, but even she mentioned my colleague of work, my physician, Francisco Tejerina, Paco Tejerina. We were together and we made some progressions. And I had to say that we are far beyond this. Very probably they know something more, but today, so I'm gonna explain. I'm gonna explain why this is somehow obsolete. Okay. So the point is that the viral reservoir, as many other viruses, at least she mentioned some debilitating conditions and many viruses, not only viruses, in general pathogens that trigger debilitating diseases. And here, viral reservoir, autoimmunity, tissue damage and dysfunctions, latent viral reactivations as independent frameworks. But actually, the viral reservoir is able to cause the different kind of damages in a cascade, actually. So this is not in the same way, but it's a cascade. So viral reservoir triggers and alters the protodynamic of the intracell protodynamic of the immunitary cells and makes some immunitary dysfunctions, but also causes damage to the endothelial cells, the anti-spike proteins, overreaction of the immune system because, for example, the spikes attached to the healthy endothelial cells and the immune system is confused, think that the healthy endothelial cells with the spikes membranes hooked in there, they think that actually the endothelial cell is infected, but actually it's not. So the point here is the protodynamics is affected, and therefore the machinery of the cell start to work wrongly. The cell becomes to have long COVID too, because long COVID is a cellular disease. That macroscopically you have also long COVID, but the cells the cells have also long COVID, and jellification of the endothelial cells and so on. I have a video in 2022 about the viral reservoir and the tissue damage and how the jellification and the microclots and so on. Yeah, we have that from the 2022. And the latent virus reactivation is the last step in that cascade, because if you have the immune system compromised and you have hypoperfusion because of the microangiopathy, of course, not only latent virus reactivation, but the bacteria in general and the tumorigenesis, because the T cells are responsible for controlling the tumorigenesis. Tumorigenesis indeed is happening every time in healthy people, but the point is that if you have a good perfusion and you have a good immune system, everything is under control. When this becomes disbalanced, it triggers all of these symptoms. And the latent virus reactivation is a consequence, not as an independent path or a different form of a long COVID. Indeed, all of that is a cascade down of the viral reservoir. So, thank you. So, that was what I wanted to say about that. And yeah, I'm going to explain a little bit more about the waterfall. So, the SARS-CoV-2 triggers that immunodeficiency, angiopathies, and the cell dysfunction that we already commented. But because the intracellular proteodynamics, actually the interactome, the intracell of the host interactome is a compromise because it's sequestered. The viral proteins hijacks the cells. So, for example, the NSP1, the non-structural protein 1. So, in the ribosome, you can see it here. So, it impedes that the host proteins are translated from the host RNA and only translate the viral RNA into proteins, into viral proteins. So, the cell is not able longer to do the most important things, for example, metabolism, activation of the intracellular immune system, because there is a whole immune system of the cell, not only from the body. This is a fractal approach. There is also for the for example, I don't know, the mitochondrial antivirus signaling, everything is compromised, everything is working down. And the most important one of the cornerstones of the sequestration of the cellular machinery is the cellular crosstalk. The cellular crosstalk is actually the most complex and biggest network in the body. It's not the neurons, it's the cellular crosstalk, and the bloodstream is the telemetry medium to do that. So that's the point. If you have that sequester, of course you are going to have disorders like autoimmunity because the cells are hijacked, and of course you are going to have immune dysregulation. Also, the spike itself is able to trigger and waste all the energy and the metabolism of the overreaction of these cells until they got into senescence. Of course, they are going to have viral reactivation, and not only viral reactivation, but bacteria, Bartonella, Borrelia, and fungi, and so on. Why are many people, and even bigger and bigger and bigger population that is affected for trivial infections, at least in the past? So pneumococcal and many things. It's because of that. There is, just rough numbers, there is 30% of the people asymptomatic that they ignore they have some viral reservoir post-infection. So that's the point. After that, of course, there is the rest of the blah, blah, blah that we already know about the vascular access into the different classes of long COVID B, Z, D, and to handle symptoms. Of course, the people who know me know this classification. In Z, there is not only viral persistence. This is from 2022. So if anybody wants to know about that, just put a comment below, and I put the link of that video. But probably if you see my video, this video in my channel, there are not many videos, so you're gonna see it very easily. Maybe 2 videos, 3, not more. So that's the point. That is the rest of the cascade, and the rest of the symptoms. So the rest of the immunodeficiency, so the aberrations in the rest of the immune system, autoimmunity maybe here and here, but structural damages and all that we know is here. Viral reservoirs inside the biofilms, inside the bone marrow, inside all of that is here. And all the vascular problems and fibrosis problems, everything is here. Fibrin, amyloid, resistant microclots, which are, I call them farm, like a farm, animal farm. Yeah, farm. Fibrin, amyloid, resistant microclots is quite easy. So, yeah, the farms. By the way, many people, I've heard today, and they say it was a little bit unclear why why Omicron from Omicron after that the severity it was lower, but no zero, especially for affected long COVID. If they got reinfected, is might risk into severe COVID, long COVID. Sorry. So the point is that what I was saying. Oh yeah, the inflection point is that the efficiency, the intercell protodynamic in pre-Omicron variants were no chroma, no party. Okay, I'm gonna make here and stop. Ta-da! Magic. So yeah, as I said, the farms is the cause that is the inflection point in between before Omicron and after Omicron. So post Omicron, the intracellular protodynamics it was not so, and the spike proteins, the interaction. So the interactome between the proteins don't favor any longer the farms in the same way, and that's key. That's important. Also, they mentioned maybe I think it was Iwasaki. No. I have some annotations here. Let me see. Amy Pro. I think it was Amy Pro. No, Pretorius. It was Pretorius that they said. Basically, the things that I have in my preprint of February of this year. So 3 months ago, I think 100 reds they have, and basically the exactly suggestions that I have for proteolytic enzyme solutions to try to combat the farms, basically nattokinase, seropeptase, and lumerokinase. Now, there are more. Lumerokinase I think is better, but you have to take care with the fibrinolytic units. But there are more actually. I only put the point is the funny point is that I only put 3 in my preprint of February, and because okay, I think that's enough. And she mentioned only 3, but anyway. So going back to this, yeah, as I said, here the problem is that after that, yeah, then if in case, of course, many probabilistic case, viral reservoirs, then you have here feedback. So all the different frames that she put in a different parts, which is a picture of the long COVID of 2021, actually it's a cascade down of the viral persistence. Even in asymptomatic. Of course, there exists the possibility not to have viral reservoir, but they are by itself resolved in 12 months. The spike persistence. There is a study, also you can see in my video of 2022, from March 2022, more than 2 years. I think 25 months ago. So I said something that actually they didn't release, that it was a cohort of 20,000 personal staff of the health system in the UK, and it was a negative exponential decrease in the IgG anti-N, so the immunoglobulin G of for the nucleocapsid protein, but there was a planitia, so asymptomatic, not to 0, but a planitia decrease until a point and then get constant, and I said that in that video, and that's because of the spike persistence, not necessarily to the viral reservoir, because also happens in vaccine affected population that is negative for IgG anti-nucleocapsid. So if you have an IgG anti-nucleocapsid 0, then is 100% because of the vaccine. That was a frequent question by that time, 2022, but I still hear in that question sometimes. So the point is that yeah, there is a feedback here. So very probably you have to zoom in and make the same analysis of the cascade, but here to see the downstream and the upstream. So if we make the zoom in to that, there is the infection, and then the replicative machinery comes into action. First, the NSP3 make the first cleavage because of the node in the viral RNA that it goes from outside, and then the cleavages. Actually, the NSP3 has some flexibility. It's about 20%. 80, roughly speaking, 80% mutation if I'm not wrong. From respect to the SARS-1 in 2002. 2002. So, too many zeros and twos. So, replicative machinery, and after that, you very probably know the process, the 3 cleavage on the polyprotein, and then comes into action the main pro, which is basically the NSP5, which is a very, very good target, the catalytic residue for densitorovir or for Paxlovid. This, we made an experiment in 2022 with Pax, but for long COVID, 1 month. And today I heard that Iwasaki is still having some conclusions for 15 days. So only 3 boxes of this, and about severity. We already know that for 8 boxes, there is no. We made a study. It's actually it's not multicentrum. It's not double blind. It's compassionate use, but even the people who developed some intolerances, drug intolerances, which is very frequent because the liver and the kidney, since they are very parenchymus, from the very beginning of this, we knew in 2020, there were a problem with drug tolerance and so on. So in this case, the CYP3A4 is the metabolic route for that. In general, it has a very good tolerance. Even the people that don't tolerate even not amoxicillin or any other, for example, the human immunodeficiency virus, tenofovir, with in combination with ritonavir, is much more harder than this. So the point is, this is very effective since it goes to the catalytic diet of the NSP5. And afterwards, of course, there is the all of that, the NSP 13, which is the helicase, and then the replicase transcription complex of the NSP 7, 8, and 12. 12, the fucking bioprinter of the viral RNA. This is the queen of the viral replication, and there are a lot of very good targets there. So that's being said, I was impressed that the technology they had in the studies of Yale is that we had in even shorter than that of actually this is the picture of 2022. We have much more advanced techniques here. In I think you can now probably you cannot see it. Let me show you here in regeneratics. So sorry. So the point is that there are much better treatments. For example, in the case of the RNA dependent RNA polymerase, the NSP, the non-structural protein 12. They are nucleoside analogous, even better than remdesivir. Remdesivir has also very good tolerance, and there is no medical interaction between remdesivir and Paxlovid, for example. There are much more. We know about the a safe combination of 5. I cannot say it right now, but if you say my preprint of the February, you might get an impression of what I'm saying right now. So at least I can say that something that is quite better than that is remdesivir with Paxlovid with sotrovimab, because very effective. Most of the people who has long COVID, severe long COVID, is we say pata negra 2020 and 21. It's because, as I said, because of the farms, the fibrin amyloid-resistant microclots, that they were harder to eliminate, and therefore, the variants of that time, we have the available monoclonals, but you know, you always have to have a redundant approach of the problem. So not monoclonal but polyclonal. So for example, combine, I don't know, you have sotrovimab, but you have also endebimab, etesevimab, I don't know, casirivimab. There are a lot of them with very good selectivity index, EC50 and CC50, and that you can combine wisely. Of course, it depends on the people, and you always have to make check control every week about the viral organs, just to make sure that everything is under control. But even here in regeneratics, we have many things quite better than remdesivir right now as a nucleoside analog. Because it is it infiltrates in the viral RNA as a pseudoadenine. But the point is that, and I like, for example, that it's a prodrug. It means that it adopts the active form inside the cell. But the problem, because of the velocity of the printer, you know, the 3D printer, the NSP12, the point is that because of the size of the virus is 30k bases, so 30 kilo bases, 30,000 bases, it's too much. It's too much, and it has to print it very fast. Otherwise, the host enzymes, in spite of all the viral interactome for you know, the isolation, the interferon signaling, the interferon, different interferon paths that working inside the cell, and the, you know, the mitochondrial antiviral signaling, and the IC, I don't know, there are a lot of them, sumolization, ubiquination, there are a lot of viral processes in the immune evasion, and fortunately they are cascade down, that they don't release that, they're cascade down. So I don't know what I was saying. Oh yeah, so it has to print so fast because it's 30 kilobases, that's too much, that it has to make the insane velocity of 260 nucleotides per second. That's fucking a lot. So it needs some help to correct some prompt errors after that, and that's because the exonuclease in the non-structural protein 14 makes some changes in that, and there is also very good antiviral strategies for that path. And as I said, the NSP14 sometimes, unfortunately, is able to block the remdesivir, and that's why that technology of the Pax, sotrovimab and remdesivir is the technology that we had in January 2023. So more than 1 year, maybe shorter than 1.5 years. I just wanted to make those comments because sometimes one say, oh, this is jail, or oh, this is very famous, but sometimes they might incur into some things that, of course, everything is positive to share all the knowledge, and they did a good job. But I think they should make some progress or some advances that might help the rest of the people. I don't know. So thank you very much, and that's all the thing I wanted to say. And yeah, I don't know if there is something here more. Yeah, there is spread. I don't know if I made something here more. So thank you very much for listening, for seeing this, and yeah, if you think this information useful, then please yeah, share to other people and comment that, and yeah, you can contact with me, put a comment below if you want to make some observation, or if you want to contact to me because of something or whatever. Yeah, thank you very much. Bye bye.